the outline of my talk. I will first give some use cases to describe the breadth and depth of information extraction. Then I will describe some requirements for information extraction. After that, I will give an overview of System T and show how System T meets the requirements. And finally, I will describe some courses that we are teaching and people are teaching about System T. And we are also making an open course. And hopefully everybody can start learning and using System T. So here's the first example. Today, from the massive amount of social media data, a lot of business intelligence can be obtained. For example, companies want to know about the sentiments about their products and services. This is not simply just knowing the positive or negative sentiments. You also need to know what is the sentiment about and what are the circumstances, the conditions under which you get these sentiments. So to do this, we need to extract various attributes about the user, events, relationships, and other things that are associated with these sentiments. In doing this, we encounter various challenges: the large scale of data, the breadth of data, the different variety of things, concepts that you would be interested in, and the complexity of the data, sarcasm, wishful thinking, various idiosyncrasies in the expression. So that's one example. Let's look at a very different example. In many complex systems, a lot of log data are generated by various components, web servers, and many other parts. From these logs, we would like to be able to monitor the system health, to analyze any problems that's occurred, and also to predict situations where future problems might occur. So to do this, we have to extract the information from the logs and to analyze them and link them to build models. So the challenge here is every customer has their own setup for their systems and formats. And instead of writing any one of these from scratch, we would like to have the ability to quickly adapt to different customers' needs. So from these examples, we summarized a few requirements for information extraction in today's enterprise environment. Number one is expressivity. The system must be able to express a wide range of algorithms for different kinds of data and different tasks. The second is scalability. We need to be able to process large documents and a large number of documents and process them fast. The third requirement is transparency. So it is not sufficient to just give a result, but it's also very important to show how these results are obtained. Okay, so let me show a few examples to illustrate these requirements. On the left is a natural language sentence. We want to parse this sentence to get the parse tree. On the right is a machine log. We want to parse this machine log to obtain a number of attributes and their values. Now, if you look at the last attribute, the value itself is also a natural language sentence. So to further understand this machine log, you also have to analyze this sentence. So a system that is able to process this kind of data must have both capabilities in an integrated fashion. Now let's look at a different example just to show the complexity of information extraction. So here we're trying to find facts from tables. Obviously, you need to know the columns and rows of these tables, sections and headers. Some information are not in just one table. They are in multiple tables, in footnotes, and with different kind of correlations. So in order to express all of these rules to extract information, we really want a system to be able to express these kind of complex tasks and algorithms in a very understandable way. So let's look at, talk about scalability. Obviously, today, the amount of data is orders of magnitude larger than the traditional information extraction tasks. So we need to be able to process this kind of data fast and in large scale. Okay, the last requirement, transparency. That is a very, very important requirement. So here is an example of adapting sentiment analysis to a specific domain. So in these cases, people are not just interested in general sentiment. They want to know the sentiments about their particular products and services. So whether a particular entity is related to their product is domain knowledge. Whether a this phrase, something is elevated. Is it a good positive sentiment or a negative sentiment? Again, that's domain knowledge. Someone says a website is better. Is it a positive sentiment or negative sentiment? It depends on whether that website is your own website or a competitor's website. So all of these things need to be expressed in a way that corresponds to the user's concepts. So I have talked about the three requirements: the expressiveness, the scalability, and transparency. Now I'm going to give an overview of System T and show how it meets these requirements. So System T is a declarative information extraction engine. It has three components. It has a declarative language. It has an optimizer. And it has a runtime engine. So on the right, you see an example of System T's declarative language, AQL. One thing we can notice is that it's very similar to SQL. So the syntax is adapted from SQL, but it has additional operators to support text analytics. Because the language is declarative, the users are freed from worrying about performance and the actual steps to realize realize their tasks. So the machine can optimize the execution plans to choose the best way to get the result. So System T has a very strong optimizer. And then it has a runtime engine to execute these plans. We have studied the theoretical aspects of System T and shown that it is more expressive than prior generations of information extraction tools, and it is it has much higher performance. So to give a idea of the expressiveness, here is an example of sentence boundary detection written in Java. It has hundreds of lines of code. Here is the same algorithm in AQL. It contains two statements. These statements basically correspond to your conceptual idea of what is the sentence boundary. So system T has a set of operators, a comprehensive set of core operators for information extraction. It also supports natural language, more advanced natural language processing capabilities. It also has machine learning capabilities to support learning the rules from data instead of writing them by hand. So let's look at scalability. So the way to increase the performance of a system is not to handwrite the algorithm, but to let the machine optimize. And in this case, system T has rewrite-based rules, rewrite-based optimization. It also has cost-based optimization. And now let's also look at transparency. So here is an example sentence from which we want to extract persons. There are two results. One is correct and one is wrong. Because all the rules that's leading to this result are available, you can trace back to understand why you got the wrong result. And so instead of a black box that you can just accept, you can change the rules, improve the dictionary, and so on to get a better result. So system T also include a web tooling environment. So people can develop information extractors by programming in a visual programming environment. So it is possible to develop these extractors without ever writing a single line of code. So now I'm going to describe the courses that we're teaching and other people are teaching about system T. Before 2013, we have given a number of lectures in various universities. In 2013, we gave 3 lectures in UC Santa Cruz in a graduate class, and it was very well received. So we expanded it into a graduate course. Then many other professors contacted us and developed more classes for system T. So in order to bring this to more people, a wider audience, we developed a MOOC, a massive open online course. So the professors who taught these courses are very excited about the results. They say it's a very good experience because it provides a better way to think about information extraction. And it also provides online experience. And the students who are learning, who took these courses are also very excited. They love these courses. So we have developed a MOOC. So within this MOOC, we have a learning path with 2 classes. One introductory class that is using System T as an introduction to information extraction. Another class with more advanced features. Both of these classes have lectures, hands-on labs, and exams. So we hope that people find these classes interesting and find System T powerful and start learning and using it. So here I have a summary slide, and I also have a set of handouts that you can take, and it gives you a pointer to that online course. Okay, so I'm here. Any questions? Yes. Can you use the mic?
Concerning the language analysis, do you today integrate the, how can I say it, the truth into your text analysis? You were, for example, expressing that you could analyze today Twitter, but how do you integrate, for example, that someone is ironic on what he says?
I'm a little hard to understand. You are saying, do we have tools to analyze Twitter?
Yeah, I mean the language analysis, to understand the meaning of the language itself. How do you integrate in your tool actually the way today that someone may not say the truth, or is, I wouldn't say a lie, but is, for example, ironic? Is it that way today, or is it just a little bit too far?
I'm really, excuse me? Oh, yeah, to capture ironies in sentences. Okay, yes. System T provides the way for you to express the rules to capture these. So you can develop various heuristics, and these heuristics are explicitly expressible in System T. Okay. Any other questions? Yes. You are asking about the scalability. Yeah, so we did a study of System T compared with the prior versions of information extraction. And if I remember correctly, we are about 50 times faster than the fastest state-of-the-art system at that time. The main reason for System T being fast is we do a lot of optimization. So I didn't go to the details, but essentially, in a very large document with megabytes or hundreds of megabytes of text, in the prior version of information extraction, you might need to pass through the text multiple times. In System T, you only need to pass through it once, and sometimes not even once, because you only need to find things that are relevant to the operator that's present. Okay. Any other questions?
System T runs on Bluemix. Where does it run?
Excuse me?
Where does it run?
Oh, so System T, if you take this MOOC, it is hosted by the Open Data University. I think it's on Bluemix. But also, for academia, it is free within a product.
Okay. So we can download it.
Yeah. Any other question? Thank you.